remember it, and I have often thought this year, I wish I had taken all these notes 50 years ago, because I thought, I'm probably going to be interviewed in 50 years about this. But you know, so it was the summer before my senior year in high school, so most people can kind of put themselves in that situation. Although back then, I mean, I think our summer was a lot more quieter than for a lot of teenagers now. Hot summer, you know, hot July day out in the country with our black and white TV set. You know, that was what we had, but we'd watch the coverage of this mission, and then on that afternoon, I distinctly recall myself and my sister, also about to be a senior in high school because we were twins, and my parents, my mom and dad, you know, sitting there watching the coverage and just marveling. And you know, it wasn't a great image because technology at the time, and this was being sent back from the moon and then through all of the network to get to our TV set, which is different than how these things travel today too, in bandwidth. But watching that and just marveling that they were on the moon. I mean, it felt historic. And I already liked math and science, and I followed all of the early space program. And I was proud that we did it, you know, and I watched all the coverage that I could. I don't think so. And they were down for a little, you know, they weren't on, should have looked this up, they weren't on the lunar surface all that long, not as long as some of the later landings. But they didn't go out right away. I recall it being in the daytime.
Okay.
And you know, it was daytime on the moon. They had to go when the moon was in the right phase to have lighting. Because if you think about how the same side of the moon faces us all the time, and so they needed to go when it was around a full moon because they were on the near side for line of sight communication. So that was part of their launch window constraint. So they were illuminated the whole time, and I know they said, you know, I've read the comments about Earth looked pretty awesome, but it was only partly lit to them because they were on the other side from the sun. By that point, I already liked science and math, and although I still had my senior year to go in high school, I was pretty well, I had decided I'm probably going to major in science. So this didn't do anything, you know, to change my mind on that, right? And I did think about working for NASA, just in general. It seemed a long, unknown road from our place outside of Jackson, Missouri to NASA, and I didn't know anybody who ever worked there. And there were no women astronauts then, so it's kind of hard to see that goal. Although a lot of people behind the scenes then promoting diversity and opportunities for women are what led to me later having the opportunity to do that. But the education that I pursued first through Southeast Missouri State and then here at the University of Missouri really provided a door for me to open to go to NASA at the same time that they decided to start hiring women. So the fact that this only spurred on my interest in science was a good thing. Yeah, I was on 4 shuttle flights. I flew twice on Atlantis, alternating Atlantis and Endeavour, twice on each one, Atlantis, Endeavour, Atlantis, Endeavour. All the missions were very different. You know, I can talk in detail about all of those, but first, that was my 3rd mission. So my first one, we had a large astronomy observatory in the cargo bay, the Shuttle, that was a detector for gamma rays. And so the whole electromagnetic spectrum encompasses, you know, our visible light we're more familiar with, the high energy stuff like X-ray and gamma rays and radio waves and microwaves and infrared, and all of that is part of light. And we're interested in all of it, but we have to go to space to see the short wavelengths, the high energy things, because that doesn't come through our atmosphere, which is actually good in general. But this observatory, we were going to leave in orbit around the Earth. We were going to take it up, lift it out of the cargo bay with a robotic arm, which I got to do that. And it stayed in orbit for 9 years, collecting high energy radiation from very energetic astronomical events that go on around the universe. And then it was named the Compton Gamma Ray Observatory. So it was really fun to be a part of that. My second one, so that was an outlooking, you know, observatory that we left in orbit. My second flight was studying our own planet. And so we had a suite of instruments in our cargo bay that included a very large antenna that emitted in 3 different wavelengths in the microwave range that basically bounced off the Earth and came back and were detected by this antenna. And the fact that we were moving while it was waiting for it to hit and come back, we would move some small finite distance in our orbit that effectively simulated a larger antenna. So it was good for the resolution. And it was studying Earth science in the sense of we had sites that were deserts, snowpack, biomass, looking at deforested areas, ocean currents. It was an international group of investigators that had sites around the world that were being imaged by this, basically in these wavelengths that our human eyes couldn't see. And it also goes through weather and clouds, so that was a very nice aspect of it. And then we had another palette with instruments that were studying what's in our atmosphere, including CO2. On my final mission, we brought up, at that time, the crew size was 3, because it had a lot of the habitable structure up there then, not all of it, but a lot of it, but it didn't have as many solar panels, and so they were limited to 3 people full-time. And we brought up 3 people. We brought up 2 Americans and 1 Russian, and we were bringing home 2 Russians and 1 American. Was on that flight. So we did that crew exchange. We also had a big cargo module in our payload bay of the shuttle that is kind of like the UPS delivery truck arriving, right? And we used a robotic arm to pick that up and attach it to the space station. And then from the inside of the space station, opened the hatch and unloaded everything, and then we had to reload it to bring it back with things that they didn't want anymore. But they really cared where we put all of that stuff because the center of gravity mattered when we put it back in the cargo bay, because this vehicle was going to come back and land. And so you care about where the center of gravity is of your airplane. It has to be within limits. And so we unpacked, and then we repacked that. And I guess I would say call it the load master for that module. And so that was kind of my job, to make sure we checked everything off. We took it out and when we put it back in. For quite a while, NASA's goal was not very specific. So I like the fact that they finally said we're going to do the moon, because they were developing capability beyond low Earth orbit, but it could be the moon or Mars or an asteroid. It was just a little bit unfocused. So I think the moon is a good focus. And I think prior to this 2024, they were looking at maybe 4 people down on the surface later in the 2020s, like maybe 28, 29, and now there's been this retargeting to do it by 2024, which I think is going to be a scaled back, maybe 2 people on the surface, maybe a couple in orbit, which means they're looking at a different lander, probably capability. I don't think the lander, and I could be wrong here, this is not my daily role anymore, but I don't think they've done much on the lander. So I'm a little, it's a pretty quick development time, and I think there's been some money promised for the next year. So I'm enthusiastic about going back to the moon. I look at it's going to require several $1 billion more each year, and I wonder about that. So time will tell if the money comes through. I mean, Apollo sucked up a lot of money. And even, after the first landing, even though we did more landings before. But yeah, it is hard to keep that in front of people right now. I mean, it's not very well known that we've had humans living in orbit around the Earth full time since later in the year of 2000. I mean, that's a lot of time. And in its own way, that's an impressive project. As the shuttle was, for 30 years to keep flying with, of course, 2 really big tragedies. I mean, Apollo still stands out because they went to the moon. But for Shuttle, I wonder if we'll ever have another project that lasts 30 years or will do all of the things that those vehicles did. And because it turned out to be a very complicated machine to fly and turn around and launch again. That was Columbia, the second one that we lost, and that was really due to an ascent issue with a piece of foam breaching the leading edge of the left wing. And then it was no longer able to keep the attitude. Well, the heat got in and just started messing up the inside of the wing, and it was yawing out of. Both shuttles really broke apart because of dynamic forces with their velocity going through the atmosphere, because if you can't keep the right end forward, that's too much stress. And that was so tragic. Mars is going to be difficult. I hope I see it in my lifetime that humans go. I may have to really try to extend my lifetime. It's just, even if there's some kind of constant threat, with today's technology, you could do about because this is what a robotic spacecraft take, about a 6-month trip there, and about a year on the surface if one is going to return. Of course, that hasn't been done yet. And to get the optimal alignment around 26 months later, you've got to wait to come back. So these are going to be 2-year-plus missions. That's a challenge to take all of your stuff, and I'm sure there'll be, supplies will go first before humans. So that's a lot of risk. It's a lot of things going right. It's a lot of resources, including money. I mean, really, really expensive. And so I just wonder, we could do all of these things. And we could do the other things that need doing on this planet that sometimes get criticized. The money's not going for that. But it doesn't seem to be how we manage our finances in general. But we can go to Mars. I mean, we have the technology to figure out how to do it, to know how to do it. Landing on Mars is challenging, particularly as things get more massive, because you got to take a lot of fuel with you if you're going to try to slow down going in. The atmosphere doesn't help much for braking because it's very thin, but yet you have to worry about it for the heating effects, so you have to take it into account. And we've had some really unusual ways that even our probes so far have landed on Mars, all the way from the complicated Curiosity that had this, just really interesting animation on YouTube that shows how they did it, how, it came down on a parachute, and then, that was off, and then it had this sky crane, and then it had to have little retrojets. At 1/3 G, that's another thing we can tell from the moon, be interesting to know long-term, living in 1/6 gravity on the moon, how does that compare to one long-term microgravity, 0 G basically in Earth orbit? And so then I think, we can figure out, what's gravity, what's that going to do for humans, a year on Mars? What's that going to do to their physiology? What are they going to feel like coming back? And it would be quite an adventure.